Question 7. The particle of mass m2 rests on the surface of a smooth inclined plane, so no mu. m1 is hanging off here. And we're asked to show the downward acceleration of m1, so downward, m1 going down. So let's draw the diagram for m1 then. m1, change it to A or B if you want. So we have, maybe we will change it to A. Let's change it to A. So we have A times G. We have tension in the string. It's going down, so acceleration of small a. Then we have m2, let's call it B. I know you guys hate the m1s and m2s. Coming down, mg, my angle A, I have bg sine A here, and bg cos A here, and I have my string. So are we given any information about the angle? We are not given any information about the angle that I can see. Yeah, because sine A is in the answer here. Okay, read the question first, maybe might be a good idea. Okay, so let's have a look here. Our diagrams, or our forces. So we start with A. So we have downward, so AG minus T is equal to MA. So that's A times A. And for this diagram, it's moving up. So we have T minus, what's opposing it? This BG sine A. BG sine A is equal to MA. So that's B times A. Bringing these two equations together, our T's will disappear. So we're going to have AG minus BG sine A is equal to A times A plus B, or AA plus BA, but A times small a times A plus B. And we're asked to show that acceleration is equal to something. So we have this G on the left. I'll factor that out first to get A minus B sine A equals, I'll leave the A there and divide by A plus B. And actually that looks like the answer that they were looking for. If we change A back to M1, we get G times M1 minus M2 sine A over M1 plus M2 is equal to my acceleration. And just double check, we have M1 minus M2 sine A. Yep, it's all looking the same, so that's perfect. Deduce that the M1 mass will move down if M1 is greater than M2 sine A. Well, let's look inside here and see what we have. M1 and M2. So we're asked to show that M1, well, if M1 is greater than M2 sine A will be positive, won't it? This will definitely be positive. A will be greater than 0. Therefore, so we're looking for here, M1 moves down. That one's a bit obvious, but sometimes it's maybe the obvious ones, they're a little bit tricky to kind of understand what they're asking. If M1 is less than M2, we're going to get, say, 4 minus 6 in here. We might get 4 minus 6. If M2 sine A is 6, and we'd have a negative acceleration, so it's going to move up because we took the forces direction to be positive acceleration going in that direction. And describe what will happen to the M1 mass in the case M1 is 1 and M2 is 3 and A is 30. Well, let's just fill in information in. What will happen? A is equal to G times M1, which is 1, minus M2 sine A, 3. A is 30, sine 30 is a half. So 1 minus 3 times a half over M1 plus M2 will be 4, or 1 plus 3. So we're going to get G over 4 times 1 minus 3 over 2 is minus 1 over 2. So we're going to get minus G over 8. So therefore M1 with negative acceleration will move up.